Rational root theorem. I'm using a lot of synthetic division or synthetic substitution to be able to do the rational root theorem. Basically, you're trying to find values a different way, because if I have a polynomial, let's take a look at problem number 3. We have 2x cubed minus 5x squared minus 4x plus 3. We're trying to get this to equal 0. We're trying to make this equal to 0. Well, we don't have any technique in regards to factoring this down. Yes, we could try by grouping. Grouping would be the only way we can have of doing this. Well, if we try to group this out, it's not going to be able to help us solve the problem. Because ultimately we want to get this into a multiplication property of 0. We're trying to get to see what values make this equal to 0. So we have to find other methods of madness to be able to calculate our values to solve this equation. And that's where the rational root theorem comes in. Well, if we take a look, what we looked at yesterday, how we started this out was number of positive solutions, or I'm sorry, total number of solutions. Number of positive solutions and number of negative solutions. The first idea is to take a look at the number of total solutions. If I'm going to try to find the number of total solutions, Dad, what's the number of total solutions? 3. How'd you get 3? Yeah, it's the degree of the polynomial. So we know we're going to have 3 solutions. 3 solutions. Now, if we take a look at the number of positive solutions, that will tell us, we can tell number of positive solutions by the number of sign changes from going to left to right here. So I take a look at the number of sign changes. Start out with positive, I go to negative, stay negative, go back to positive. So Jordan, how many sign changes do we have? We have 2 of them. So that tells us that we have 2 positive solutions, or we can subtract 2 from that and get another option also. So this will be 2 or 0 positive solutions. Now, what we talked about yesterday is how we can find negative solutions. Negative solutions, you put negative x in for x and then count up the number of sign changes. But sometimes we make mistakes with that because we have negative and exponents. So we can also take a look, well, if I have 3 total solutions and my maximum number of positive solutions is 2, that means my maximum number of negative solutions would be what then, Vivi? 1. It would be a value of 1. Because I can only have 3 solutions here. If 2 of them are positive, then one of them has to be negative. Or I could put negatives in for I can change my signs to any odd exponents. This would be negative, this would stay negative, this would turn to positive, and this one stays positive. So if I take a look at my sign changes, I'm negative, negative, I change 1 to go to positive, I have 1 sign change. So either way, you choose to skin the cat there, you can do it. It's up to you. Next thing we take a look at is possible solutions. Possible rational solutions. Rational solutions are fractional solutions. And how we find that is plus minus the constants, factors of the constant over plus minus the factors of the leading coefficient. So we have plus minus factors of the constant over plus minus factors of the leading coefficient. Now, what I tend to do is I just write my factors down. See, my factors of 2 are 1 and 2. My factors of 3 are 1 and 3. So we can then go through and take a look at, well, I'm going to take my constant factors divided by 1 and my constant factors divided by 2. Well, if I divide 1 by 1, I'm going to get 1. I divide 3 by 1, I'm going to get 3. So we can start this out with just plus minus 1, plus minus 3. That taking both of these, dividing both by 1. Then typically what I do is if I have another constant here, another factor here, I just write beside and divide these by 2. So we have plus minus 1/2 and plus minus 3/2. What we have now done is we've taken the whole real number system, which is our domain, because our domain could be any value that will make this equation work. That's my domain. And narrowed it down to just 8 values. 8 real numbers that would make this equation work. So at this point it becomes a trial and error type of way, that method. I typically do not start with the values of 1. If you want to, that is fine. I typically start with another value here. And we can run this through synthetic substitution. Because all we're trying to do is, okay, I'm saying, let's take the value of positive 3. Let's sub it into this to see if it makes it equal to 0. Now, I know I can clickety clack that through the calculator. I understand that. But we're going to use synthetic substitution. You need to show me that synthetic substitution. So we have our constants, or our coefficients 2, -5, -4, and 3. And what you hope for is that, you get 1 right off the beginning. So I run this through synthetic substitution. Does it work? Does 3 work? Hey, we got lucky. If it didn't work, I'd have to try another value. Right through, we have 2, 6, 1, 3, -1, -3, 0, winner, winner, chicken dinner. So x equals 3 is the root, or the solution, what would be the factor? What would be your factor, Kristen? X minus 3. Well, if x minus 3 is my first factor, I can then write down a second factor. Mickey, what's the second factor?
2x squared plus x minus 1.
Which when I get into a trinomial, I could factor this down. I'm not going to continue through synthetic division. If I wanted to go through synthetic division, I could do that. But if I get trinomial, I'm going to go back to my old school ways of being able to solve a problem. So if we have x minus 3, we're looking at 2 other factors. So I look to factor down 2x squared plus x minus 1. No, what's our 2 other factors?
2x plus 1, x minus 1.
So if I check my middle multiplication, I get a minus 2x, I get a plus 1x. Does that give me plus x? I get a minus 2x and a plus 1x, so I get plus 1x here.
Yeah. I have minus x.
Does,
The sign.
does my middle multiplication work out? my first and last are gonna work out, cause I set it up that way, but I have to check my middle multiplication. I got a negative 2x and I got a plus 1x,
It
doesn't work. Okay, I get the wrong sign there, so if I get the wrong sign, all you gotta do is just flip your signs around. So we just flip our signs around to make this a plus and this a minus. Now if I check my middle multiplication, I got a plus 2x, I got a minus 1x, I now get a plus 1x. So each one of these factors could equal 0. By my multiplication property of 0, each one of the factors could equal 0. So my other solutions, I have x equals negative 3 as a root. My other two solutions would be what, Mickey? 1/2 and negative 1. And my factors are 2x minus 1 and then x plus 1. I just note them there. And if I take a look, here's my positive 1/2 up here. Here's my negative 1. Here's my 3 up there. Those are my solutions. If I take a look at my positive, okay, I said I'm going to either have 2 or 0 positive solutions. I have 2 positive solutions. I'm going to have 1 negative solution, and there it is. Just a lot of subbing in, a lot of synthetic substitution. If you go on the back, in problem number 5, we have 5 solutions. My possible solutions are plus minus 1, plus minus 2, plus minus 3, plus minus 5, plus minus 9, plus minus, I don't need 2 in there, plus minus 15, and plus minus 45. And if I take a look, and this is why I don't start out with the value of 1. We have 1, 3, negative 18, negative 22, 81, and 45. So negative 45. If we start out with 3, and we run 3 through this, we have 1, 3, 6, 18, 0, 0, negative 22, negative 66, 15, and 45, and we get 0. If we take a look now, x minus 3 is going to be the factor. Now we're going to do this up above. X minus 3 is going to be the factor. The other factor is x to the 4th plus 6x cubed plus 0x squared minus 22x plus 15. That's my other factor. And I want to continue to factor this down. Think back to prime factorization. If we had the value of 12, we can factor this down into 2 times 6. These are one of my favorite things when I was in elementary school. I don't know why, prime factorization trees when we were in 5th grade. 4th grade did the prime factorization trees. I thought those were pretty cool. I don't know why. Because I was a math nerd, I guess. We can continue this with 2, but then we break down the value of 6 into 2 times 3. Well, we divided the 3 through here, and we come down to this new factor. My constant now is 15. So what I'm able to do is if I look at my list, my constant's now 15. Which factors could we eliminate, possible factors can we eliminate from our list now? Well, what are factors of 15? Isaac, what factors could we eliminate? 9 and 45. These will not work now. Why? Because I just have 15 left. So I want to now, just like I took the 6, I want to now take the next one down. Okay, and I'm going to cheat here because just to save some time. Negative 3. 3 could work again. Just like we have a factor of 2, we broke 6 down into 2 and 3, so 2 worked twice. So I'm going to run 3 through. 1, negative 3, 3, negative 9, negative 9, 27, 5, negative 15, and 0. So we have x minus 3, or x equal negative 3 is a root. And if I take a look now, what happens, I have the x minus 3 initially, then I'm going to have an x plus 3. Now I have an x to the third plus 3x squared minus 9x plus 5. So now I can eliminate other factors over here. 3 doesn't go into 5. 15 doesn't go into the 5. So the only ones that can still work for this are either 1 or 5. What I'm trying to show you is that if you use the 1, that constant term at the end is not going to go to a different number. So you won't be able to eliminate any of the factors or any of the other possible roots. But if you use others that are not 3 or not the value 1, you can start eliminating other possibilities over here. For the more extensive ones, I'm not going to substitute fractions in unless I have to. I'll list them there, but you know what? I'm not going to sit there and go through fractions. I'm just going to do my whole numbers, and hopefully my fractions, like in the first one up here, my fractions can be factored out. Other questions that you have? Okay, worksheet today. There's some additional types of problems in at you. Yes, some syntax. I'm sorry, substitution. You have a long division problem. first couple are rational root problems again. Now if you go to the back, you have synthetic substitution, long division. Sort of a combination of all the things that we've done up till now. Monday will probably be a review day over this material. I'll probably get a quiz on Tuesday. Cover this. Then we'll continue on within the chapter. Probably could have done the class assignment today, but we'll take that one off. We'll just let you work on your homework for today. Okay, the rest of the time is going to be yours. Solutions will be up there. And then we'll get some solutions posted.